Hello, Algebra 1 students. Today we're going to be taking a look at some important features of absolute value functions and their graphs. So we're going to be looking at the parts called the x-intercepts, the y-intercept, and the vertex. And before we actually get to graphing them, we're going to be finding where those points are. So we have a function here, f of x equals the absolute value of x plus 1 minus 2. And we're going to first look at finding their x-intercepts. But before we do, let's remind ourselves what an x-intercept is. So let me quickly draw a coordinate plane. And I'm going to draw some random graph. That's a weird looking function. But the x-intercepts are going to be the points in which this graph crosses the x-axis. So let's take a close look here. The x-intercepts on this graph would be here, here, and here. So this graph would have 3. That's the points we're trying to find in this function. Now take a look at those points a little closer, and you're going to note that they all have something in common. They all have the same y value of 0. So we're going to use that so that we can mathematically find our x-intercepts of this absolute value function. So we're going to make our value of y 0. And also remember that f of x is the same as y. So here we go. 0 equals the absolute value of x plus 1 minus 2. And now we have to solve for x. So let's give myself a little more room here to do that. And let's solve for x. Well, first I know we can add 2 to both sides of this equation. We get 2 equals the absolute value of x plus 1. And now we have to split our equation into 2 parts, because this absolute value can equal what's inside the absolute value can equal 2, or it can equal negative 2. So let's see that. X plus 1 can equal 2, because the absolute value of that would still equal a positive 2. And x plus 1 could equal negative 2. And that's because what's in here can also be a negative number and still come out to be a positive 2. So we're going to solve these separately. Let's first do the left-hand equation here. Minus 1, we get x equals 1. And on the right, we get x equals negative 3. So these are the values of x when y equals 0. So we're going to write our final answer, or answers, like so. 1, 0, and negative 3, 0. And these are going to be the 2 points on our graph that cross the x-axis. Next, let's take a look at finding our y-intercept. Again, let's remind ourselves of what these look like on a coordinate plane. Imagine I have this as my graph. Take a look. This is at 0, 0. Let's draw a different graph on this coordinate plane too. What if I had something linear maybe? Notice its y-intercept at 0, 6. Notice the thing they have in common. Their x values are both 0. So when we find our y-intercept, that's what we're going to do with x. We're going to plug a 0 in for x. So let's begin that. We have y, remember f of x is y, equals the absolute value of 0 plus 1 minus 2. So we just need to simplify. We get 0 plus 1 is 1. The absolute value of 1 is just 1. I'm just going to erase that. And we get 1 minus 2, which is negative 1. So this is our y-coordinate of our y-intercept. But remember, our final answer is a point where 0 was used for x and -1 is y. So that is our y-intercept. Moving on, our last important feature of the graph of an absolute value function is the vertex. So here's how we go about finding our vertex. First, find the absolute value in the function. Found it. And we're going to take that and we're going to set that equal to 0. The contents equal to 0. And we're going to solve for x. Let's do that. -1 from both sides. X equals -1. This is going to be the x-coordinate of our vertex. Now to find our y-coordinate. Well, we know what the x-coordinate is of our vertex, so we're going to use that value of x to find our value of y. So we're going to say f of -1. That's our value of x, right? We're plugging it in. Equals the absolute value of -1 plus 1 minus 2. Now we just need to simplify. So -1 plus 1 is 0. The absolute value of 0 is just 0. And 0 minus 2 is -2. So we end up getting that y equals -2. And we're just going to put both of our answers together for x is -1 and y is -2. And here is the coordinate pair for our vertex. Now we're going to take a look at a second example. Here we have the equation g of x equals the absolute value of x plus 2 plus 3. Let's change it up and start by finding the vertex. Remember, to find the vertex, we need to take the contents of the absolute value, in this case, x plus 2, and set it equal to 0. And then we're going to solve. So we subtract 2 from both sides of the equation, and we get x equals -2. Second, we're going to take that value and plug it back into our original equation. So we get y equals the absolute value of -2, because that's our x value, plus 2 plus 3. Now we just need to evaluate. We get y equals the absolute value of 0 plus 3. The absolute value of 0 is 0, and 0 plus 3 equals 3. So we found our value of x. We found our value of y. We put them together, and we have the coordinate pair for our vertex. Next, let's find the y-intercept of this function. Remember, to do that, we need to plug a 0 in for x. So let's go ahead and do that. We get y equals 0 plus 2 plus 3. And now we'll evaluate. Y equals 0 plus 2 is 2 plus 3. The absolute value of 2 is 2, and plus 3 equals 5. So we get y equals 5. And the coordinate pair for our y-intercept is then 0, because our x value was 0, comma 5. And we have our y-intercept. Lastly, let us find the x-intercepts of this function. Remember, to do so, we just need to plug a 0 in for y. Remember that g of x is y. So let's begin. We get, we'll zoom in, 0 equals the absolute value of x plus 2 plus 3. Now let's solve for x. We subtract 3 from both sides. We get -3 equals the absolute value of x plus 2. And now we've run into a problem. Take a close look at this equation. Can you spot the issue? First, let's remind ourselves what an absolute value represents. For example, the absolute value of 3 represents the distance that 3 is from 0 on the number line. And we can count 1, 2, 3. The number 3 is 3 away from 0 on the number line. Similarly, we can find the absolute value of negative 3. On the number line, how far away is it from 0? It is 1, 2, 3. 3 away from 0, so the absolute value of negative 3 is also positive 3. Where in your life have you seen a distance represented with a negative number? Well, the distance between my house and my school is 30 miles. That's a positive number. The distance between here and my living room is about 50 feet. It's a positive number. What if I walked there backwards? It doesn't seem to work. There is no distance that we measure with negative numbers. So when we see here that the absolute value of x plus 2 equals a negative 3, this is basically nonsense. We can't have a distance be a negative value. There are no x-intercepts. And that's because there is no value of x that will ever make that equation true. So, we have no x-intercepts, we have a y-intercept at 0, 5, and a vertex at negative 2, 3. I hope this example has been helpful to you. I'll see you next time.